Hidden quadratics is next. Now, this really is quite sneaky. If you look at the equations we're dealing with here, quite challenging. The question says, by identifying a suitable substitution, rewrite the equations as a quadratic in y. Now, there are no y's there, and solve first for y and then for x. Now, this section is called hidden quadratics, but it doesn't look like there's any quadratics there. Remember, a quadratic is a piece of algebra that has an x squared in it. We're used to seeing it with x squared x and a constant or a number, and those are trinomials or three-term quadratics, special types. But as long as it has an x squared in it, it is a quadratic. All right, so let's see what we can do with this. So it doesn't look like a quadratic. However, if we inspect it a little bit more closely, we've got a power of 2x up here and a power of 1x up here. So it does feel a little bit like x squared, x, kind of, but not exactly. So it's said to rewrite it as a quadratic in y. Now, I'm going to ask you to trust me for a second. I'm going to take a bit of a leap. And this is a step that I need you just to learn. You shouldn't be trying to figure this out for the first time on the day of the exam. We should become familiar with seeing these types of questions and know the first step to take. So I'm going to rewrite this 3 to the 2x as 3 to the x to the 2. Now, from our laws of indices, which are in your formula booklet, we know that when you've got a power raised to another power, you simply multiply the powers together. So this 3 to the x to the 2 is the very same as 3 to the 2x. I'll leave the 10, multiply by 3 to the x plus 9 is equal to 0. So maybe it's feeling a little bit more like a quadratic. I've got a something squared and then just the something and the constant. 3x squared, 3x term and the constant. So what I'm going to do now is I'm going to do a substitution. I'm going to let y be equal to 3x. Now, this isn't a step I would expect you just to be able to figure out on the day of the exam if it's the first time you've ever seen it. These are common enough types of questions and you should be familiar with them and you should be familiar with what these first two lines are. After this, your instinct will kind of carry you through a little bit. So I'm going to let y be equal to 3 to the x. So I'm going to sub in, instead of 3 to the x, I'm going to call it y. So instead of 3 to the x squared, it's y squared. Negative 10 is negative 10 times by, instead of 3 to the x, I'm going to sub in y, 10 times y, plus 9 is equal to 0. Now look where we are. We're back again with our three-term quadratics. We're back in a safe space. So let's just do our magic with this. I'm going to go straight to double brackets if you don't mind. I'm not going to go through the whole splitting of the middle term business. You can go back and look at the Algebra 1 video for that. So it's going to be a 9 and a 1 and a minus and a minus. Yep, that's all correct. Minus 9, minus 1. So y is equal to 9 and y is equal to 1. Now, but this is an equation in x, so I need to solve it for x. What I've done is solved for y. Now remember, we introduced a y. There wasn't a y in the question. We introduced it to kind of force a situation that would allow us to move forward. So what I'm going to do now is I'm going to sub back in, sub y equals 3 to the x back in, which gives us 3 to the x, instead of y, it's 3 to the x is equal to 9. Instead of y, it's 3 to the x is equal to 1. We're going to use our knowledge of the laws of indices, which we'll practice a lot more of in module 3, but you should have some knowledge of this from your previous studies. So I've got 3 to the power of what is equal to 9? Well, I know that 3 to the power of 2 equals 9. So therefore, x must be equal to 2. Then it says 3 to the power of something is equal to 1. And again, from our laws of indices, we know that anything to the power of 0 is 1. So we know that x must be equal to 0. 3 to the power of 0 is 1. And those are my solutions. All right. Next question is kind of similar. You've got a 2 to the 2x and a 2 to the x. Look at my first line and my second line, and you should be okay after that. Pause and have a go. All right, we had to use another one of the laws of indices there, that when you have a power below the line, you can bring this whole thing up above the line and your power will change either from positive to negative or negative to positive. Here, 1 over 2 to the 2 became 2 to the minus 2. So what we were doing here was we were making our bases the same, because as soon as your bases are the same, you can equate the powers. So if 2 to the x is equal to 2 to the minus 2, then we can say x must equal to minus 2. Right. Right, so this one looks a little bit different again, but if you look a little bit closely, you'll see we've got this something squared plus 5 times something plus a constant, which does feel a little bit like a trinomial. So let's treat it as such, and let's tidy it up a little bit by using a substitution. We're going to let y be equal to that bit inside the bracket, so then we'll be able to say it's 2x plus 1 squared, and we're letting y equal to 2x plus 1, so we can call this y squared plus 5 times y plus 4 is equal to 0. We've got a nice quadratic there, straight into the double brackets, or whatever method you use to solve. 4 and 1 plus 4 plus 1, is that right? 4 plus 1 is 5, yeah. So y is equal to minus 4 and y is equal to minus 1. So we now need to sub back in. This one is easier actually than the previous, isn't it? Because the powers and the laws of indices were sneaky in the last one. So instead of y, we're going to call it 2x plus 1 is equal to minus 4. 2x is equal to minus 4 minus 1 is minus 5. So x is equal to minus 5 over 2. And I've then also got, coming from here, I've got 2x plus 1 is equal to minus 1. So 2x is equal to minus 1 is minus 2. X is equal to minus 1. So those are my solutions. Again, you can sub back in if you want to check. Pause and have a go at the next one. All right, okay, so that's all we need to do there. I would really suggest you go to your textbook and practice some more of these because they're just sneaky and you need to practice a lot of them to make sure you're very familiar with them and you'll recognize them straight away.